I think I'd be retired by now if large language models existed back then. because, but it was brutal. We had I took apart a Wiimote, for example, like the early Wiimotes that had Motion Plus sensors. I was able to like use those IMUs and decode them in MATLAB to get like position acceleration, like all those things that came out like 15 years ago. There's people using the Wiimotes for like a bunch of different stuff, and they hacked them. So we ended up doing that quite a bit.
Welcome to Software Unscripted. I'm your host, Richard Feldman. Today I'm talking with Kyle Boddy, the founder and CTO of Driveline Baseball, which is a data-driven player development company that's put a bunch of baseball players in the pros, including multiple Major League Baseball most valuable players and 2024's #1 draft pick. We talk about some of the unusual software engineering problems he's had to solve as he built this company up from essentially a one-programmer, zero-funding garage operation where he wrote all the code himself into the successful and groundbreaking business it is today. I can tell you right now, I would not have guessed how big a deal large language models turned out to be for a company that uses technology to train baseball players. I want to give a massive thank you to everyone who's been supporting Software Unscripted on Patreon. If you enjoy these episodes and you'd like to become a supporter too, check out patreon.com/softwareunscripted. And now, software for elite athletes. All right, Kyle, thanks for joining me.
It's great to be here.
So, in the early days of Driveline, you had some ideas about how to do baseball training better, and no team, no technology, and you basically built it all yourself with a lot of DIY type stuff. Can you just tell me some stories from those early days?
Yeah, no funding, nothing, still none.
Yeah.
Employees own 100% of the cap table, so that's not changed.
Wow.
Not that there was much of a cap table 10 years ago, but yeah, some of the things we first started doing was like, how could we synchronize high-speed cameras? Like that was a really interesting challenge because the first high-speed cameras were coming out before your iPhone ever had one, years before your iPhone would ever get one. We bought a bunch of these cheap consumer high-speed cameras that, Casio was selling to like sports fans. And they were, how do you synchronize them? Because they don't have like a cable to synchronize them, so how do you do it in software? And it was like a lot of mathematics, like discrete mathematics, and reading up on some old texts and linear algebra, and then implementing them in code. So that was the first kind of big challenge that we had, which was a lot of fun.
Nice. Okay, so this was just basically like, you got this, what year was this?
Oh, geez. Probably like 2012, 2013. Yeah.
Okay, right. So iPhone is out, but doesn't have high-speed stuff yet. So
Yeah.
you're getting these sort of off-the-shelf high-speed cameras, and the problem is that you're, I guess, multiple angles. You're trying to capture people from multiple angles.
Exactly. Yeah, it was probably more like 2008, actually. 2008. It was probably even before that, yeah.
Oh,
So you
wow.
have multiple
Okay.
angles, and then how do you reconstruct it into a three-dimensional image? Same thing that we still deal with today. People take it for granted, like on your iPhone, you can download the Luma Labs app and scan. You can use Gaussian splatting to reconstruct things like that, but nothing like that existed, for that long ago.
Yeah, so if I remember from talking to you back then, I might be totally misremembering, but I could have sworn that it was controversial, the idea that it was possible to give people significantly higher velocity. And you were saying like, that's key. If you want to get into the major leagues and play professional baseball and you're a pitcher, you have to be able to throw the ball a certain minimum speed or no one's going to take you seriously. And people were saying, well, you can't really train that much. And you disagreed, I guess.
Yeah, it just didn't make sense. Like there was no way to get better at these things. And I just felt that there had to be some answers, and medical textbooks and technology could explain it. And there just really wasn't. Like no one was doing first party research or experimentation. It's the classic, if you work in academia or medical stuff, the research is pretty much, segmented to like sedentary individuals, not elite athletes. So you're not learning a lot. And all the funding goes to like gait research, like walking and stuff like that. So throwing a ball is like very low on the list of funding. So as a result, I just figured that we would have to collect a lot of our own first party data. I didn't realize how hard it was going to be, but yeah, it was fun.
Okay, so you were doing the high-speed camera stuff to study things, just like was it more for individual players at that point, or early on was it just sort of like, I just need to understand how the pitching mechanics work so that I can come up with a program that people can follow to get better?
It was, both kind of in parallel. I was, coaching high school, little league, and I was coaching individuals, but just something in the back of my mind was like, there's got to be something better than just like teaching them the basics out of a book. Like there's got to be some way we can glean some information, because from my perspective, from like a first principles perspective, there's got to be a way that we can get much more precise feedback on how a player is doing. And there wasn't that concept 20 years ago, 15 years ago. It was still really like not there. It's all human intuition, what someone wrote in a book. It's like basically folk wisdom, and I just felt that to take a more scientific, data-driven approach, there had to be a way to do that, and no one was doing that at the time.
So even in like Major League Baseball, I mean, they weren't at that time doing like high speed cameras like on their own players to try to figure out ways to improve it. That was just you in your garage in Seattle.
Yeah, pretty much just me. You had a couple academic people. There were some people like Tom House and others were using these really expensive motion capture labs, but no one was using it like as a training operation. Like no one was actually folding it into their operations.
So you wrote code that synchronized these things, right? Like you personally did.
It's very painful, yeah. I had to relearn C and C++ all over again. Yeah.
Oh, wow. So that was like the only way, I guess, to get it to be fast enough to like synchronize, or?
Very funny. We actually just ran into this problem again, like a couple months ago. Like basically, we had to write custom software to synchronize like a force plate, so like something in the ground that measures like 1,000 times a second, like not just the intensity, but like the direction and tracks, stuff. And how do you synchronize them with our cameras? So we used to have software that we bought off the shelf that would do that. Like a lot of things here, that software is not enough. Like we had to take it to the next level.
Right.
And for all the software developers out, all the electricians and electronics experts, we use Genlock, or typically the cameras use Genlock. So it's like an electrical sync pulse that sends out a pulse every 20 milliseconds. And all the devices on the ring basically can monitor that electric pulse, and then they synchronize to like the leading edge or the falling edge of the signal. And that's how you synchronize things. So that was fine. The software just handled it. It's like pretty understandable how to do it, but then, okay, we have to write our own software. No big deal. So we just monitor that pulse, and then we were ingesting it, using like an Arduino board or a Raspberry Pi, and then basically trying to connect our force plates that way. It just turns out that Python's not going to cut it. Like interpreted languages are just way too slow. So then we ended up, our engineer actually ended up dusting off. He had never written, I don't think he's ever written a line of C++ in his life, or C. And that was, he was able to basically just take these Python files that he had written and then use them in an LLM and be like, how would I do this in C? And then he literally wrote C code from scratch using a large language model, which is just phenomenal. And so when people say like these large language models and stuff have like very little impact on society, I'm like, dude, it took me like 2 semesters to learn basic C++ stuff, and my engineer was able to write a synchronization program in like a week. So just
wow,
it's nuts. And he's an electrical engineer. He didn't study computer science or programming. So obviously he can write code and has for 10 years, but he doesn't have any formal training in it. So it was really cool.
Now, okay, so the next question I have to ask is like, so you start with Python, you ask an LLM to rewrite it in C by someone who's not familiar with C, even like a little bit. Did you run into any problems with that, like any memory safety issues or seg faults or anything like that, or it just worked?
Tons of problems. Yeah, a lot of memory safety issues, of course. No, eventually, I know. It's a relatively simple problem. So you're just really just trying to get you're not really interacting with the devices that much. You're just trying to like synchronize the readings and like getting a time code sync. So as long as you can get the offsets correct, that's all the program really does. So it's pretty lightweight, fortunately.
Now, did you do that in real time, like while you're watching the? Actually, let me take a step back. So you got this force plate on the ground. I'm guessing that's like to measure the pitcher's feet when they're like doing their stance. And I don't know what the technical terms are. Like, I know that the feet are involved in throwing the pitch. Yep. That's definitely part of my knowledge. So how does that work? So you're capturing, try to get it like their arms and their body with high speed cameras, and then also measure the force on the of their feet. So I guess that's for seeing how their like ankle is moving and stuff like that.
Yeah, it's like called ground reaction forces. So it's like how much force are they putting into the ground, and like what's the force vector coming back? Like, are they, is it really up and down? Is it more horizontal? Like, is it in line with their stride? So you can get those energetics, and those things are pretty important for calculating things up the stream, like how much energy is going through the chain. So it's not just the motion of the body, but like how much force is being put into the ground, how much is like coming back from gravity. And then being able to calculate like energy flow through the body. So it's a little bit of both. You need both the optical, motion capture, and you also need the energetics side of it, which we get through ground reaction forces.
Wow. This reminds me of, so I know you and I both like to do weightlifting, like heavy, and I'm assuming you prescribe that also to your players. Yeah. But one of the things one of the tricks I learned for squat is like a trick for telling whether or not you're off balance as you're going up and down is to watch your toes and your heels. And if like your toes are wiggling a little bit off the ground or your heels are coming up, then you're not quite balanced. You want everything to be totally flat. this sort of reminds me of that. Like that's what I imagine people used to do for this stuff before you got the like motion capture and the force plates and stuff. Is just kind of eyeball it and be like, I think your ankle might be a little off there versus like having actual data. And then I'm guessing you use that for all sorts of things, not just detecting a problem, but also like how effective are your interventions towards solving it and stuff like that.
Yeah, absolutely. Yeah, and you can detect, like with two force plates, for example, you can detect imbalances for that, where like is like in a squat. So we use those force plates in our high performance lab, we call it, for our strength and conditioning. And people do squats, jumps, push-ups, all sorts of stuff. And not only can you determine like the intensity of the difference between the left and the right side of it, but you can like the force vectors. So maybe they're the same intensity wise, but like one has more outward force than it does downwards, so it's actually, super interesting.
Wow. Okay. So did you write any custom software for those, or is it really just for the synchronization? Everything else you were able to find off the shelf?
Yeah, synchronization mostly. We do write code to like parse the data that comes out of it, but it's all pretty simple. Like you're just getting time code things and CSVs of, the newtons and the directions, and then you just use Python to ingest them, and that's pretty simple. The synchronization is more the complicated stuff.
I gotcha. Okay. So in the early days, though, like you didn't have money for off the shelf stuff, I'm guessing. So
Nothing.
so what was that like writing your own, like, I mean, this was a domain you didn't know much about. I think you'd done like mainly web development, PHP before that, if I remember right.
Yep. Yeah, mostly some cursed MATLAB code, but yeah.
Yeah. Yeah. So like, what was it like learning all of the technology necessary to actually make this stuff work?
I think I'd be retired by now if large language models existed back then. But it was brutal. I'd never written Python up until maybe 10 years ago. It was all PHP. I wrote a lot of C since I knew C in college, and that's how I was trained. So I wrote quite a bit of that for the hardware stuff. Like we had, I took apart a Wiimote, for example, like the early Wiimotes that had motion plus sensors. I was able to like use those IMUs and decode them in MATLAB to get like position acceleration, like all those things that came out like 15 years ago. There's people using the Wiimotes for like a bunch of different stuff, and they hacked them. So we ended up doing that quite a bit to like measure motion of the body, which was fun.
I'm sure it wasn't like this, but I'm like imagining that like there's like a Wiimote, but like without its shell on, like strapped to a pitcher's arm, and like was that literally what it was?
I can give you a picture for it. There's a picture of me like in the T-pose, and I have a Wiimote like strapped to my chest, like duct taped to my chest, and then I extended the Motion Plus because before the Wiimotes they didn't have a gyroscope. They didn't have a 6-axis gyroscope. They just had an accelerometer. So when you play like Wii Tennis, all you did was like move the remote, and then it would like swing on the screen. It would just detect that and move fast. Right. But the Motion Plus thing had an actual 6-axis accelerometer, so you could actually detect. It didn't require the optical pointing at the screen. So what I did is like figured the pin out, extended the Motion Plus, and like took it out of its shell and put it on my wrist so I could measure. So there's like this cord running up my arm, and you can see being able to measure like the pronation, the pitch, yaw, and the roll of my hand, to use the actual terms that like computer scientists would understand. In our case, it would be like pronation and supination and ulnar flexion. Like we would use like biological terms, anatomical terms, rather than the physical terms.
Wow. So like in the movies version of this, when they make the movie about Driveline Baseball, there's going to be some sort of real-time 3D polygons, like, version of a pitcher, like in real time showing up at the same time as the actual pitcher. But I'm guessing your visualization was like pretty different than that for seeing what was actually going on. What was that like?
Firstly, the visualization was about, the latency was about 1 week, I would say, because we had to click, you had to manually digitize. And for the few out there that are listening to this that have done that, they know how painful. They're wincing right now. But imagine that you have, 4 cameras that shoot at 240 hertz, so 240 frames per second, and that we're interested in, say, 18 points in the body. Well, that's 18 mouse clicks per frame per camera, and that the delivery lasts 1.5 seconds. That's 360 frames. So 360 times 18 times 4 is the number of mouse clicks you have to do to digitize one video. And
so wait, mouse clicks though. So this wasn't automatable?
Not really. It's like click the left wrist, click the right wrist, click the right left elbow, and then every frame, our digitizer, it guesses, like it has a neural net or some sort of heuristic to guess where like the next frames will be, but it's not very good. And currently people do this all the time. They use, I think, a program called CVAT, which is pretty common. in like in the VLMs that are being used, like the vision language models or the vision learning models are use CVAT for like pre-training. So you'll outsource like 5,000 images and you'll annotate them. So not just with language, but you'll annotate, oh, there's a person in this, like CVAT, click like this. And then it's an open source program. And that's how the VLMs are trained, actually. They're very similar to what we did.
Interesting. So have those gotten sophisticated enough that now you can automate it, or is it still largely a manual process, even with that assistance?
Yeah, it's good with one camera. So there's a lot of these companies that have spun up, take video of you, upload it, or in real time, it can give you an avatar with like a Unity plugin for game design. That's great. The problem is that the margin of error is so large. It's like the Microsoft Kinects and things like that. Is it good for like game design and like stuff that's not precise? Yeah, for sure it is. But we need pretty precise measurements for the body to like be able to make like judgments on injury projection and performance, because like 1 degree of say it's as accurate as 1 degree of rotation or whatever, that's still way too inaccurate. And they're not even close to that accurate. So to give you an example, like if we have 8 cameras and we synchronize them and it's 360 frames per second, which is our current lab, the average arm measurement error using markers on the body is sub-millimeter. Like we're sub-millimeter accurate to the body.
Wow.
So that's not possible, obviously, with a single camera. It's not really possible with markerless either. So the types of precision that you need is pretty strong. So it requires multiple cameras and this whole thing. And that's like VR. Basically, virtual reality uses the same systems that we do. OptiTrack is like the dominant player in that market, and for like all those VR places, if you go to a VR gaming place, they're going to be using OptiTrack to track the body and all that. And we use their hardware and their software. It's very good. It's low cost too compared to the research grade stuff that's out there.
Wow. Did you ever try any sort of budget hacks, like let's put a different color on every part of the body, and then it's like a green screen with a bunch of different colors?
Extremely bad flashbacks. But we've tried that stuff. A trick. It's something that's interesting in like markerless. So like when we say markerless, that means like none of those dots on the body. Like you've probably seen those motion capture suits.
Totally.
A problem with markerless is that you can't measure. It's called the long axis problem. So imagine that you like extend your arm all the way and like turn it. You can tell when your palm is up and your palm is down, right? But if it's not tracking anything, like it can't track rotation about an object. Like how can a camera, if it doesn't model your fingers, for example, how can it tell that you're rotating? Because nothing's actually moving. Like there's no movement in relation to one another. And so that's actually really complicated in markerless to do the long axis. So one of our things is like you would wear a band around your arm and it would have like dots. So then you could track the dots we're rotating. And that works okay because you want another source of rotation, because rotation about an axis is actually impossible to detect with markerless. You need reference areas. And if you really think about it, they can really dome yourself up. But think about like a weightlifting thing, like how your limbs move are always in relation to one another. So like this motion is in relation to my shoulder, is in relation to this side of my arm. But like if you think about rotation around an axis, it's not relative to anything. It's like a division by zero error. So it's actually a pretty complicated problem. And so like doing those color-coded things or markers is pretty much how people do it. We tried the low budget way, that doesn't work very well.
Yeah, right. Yeah, it's really surprising that you managed to get a company off the ground with no funding, like given that it seems like a lot of the sort of hacks you would expect that you would need to do to get up and running just don't get you the quality of data that you apparently need in order to get the results that are actually better than the status quo.
Yeah, it was brutal, but who would want to fund a company? That is just, nothing. Like even today, like we're raising capital, but it's been an interesting journey for sure.
Wow. So has sort of the MLB landscape changed? Like I mean, my knowledge of sort of big sea changes in Major League Baseball is I watched Moneyball a long time ago. So like I heard about that sort of sabermetrics changing the game, but like, do people actually do their own motion capture in Major League teams now, or is it still pretty much just you guys out there doing that?
No, it's everyone's pretty much doing it now. Yeah, they're using systems called like Hawkeye, for example, or Kinetrax or Thea 3D. Like there's a bunch of different companies that get that data. Whether they use it or not, and like how they deploy it is suspect. I think that's kind of where we come in. Like that's what we've been doing. We've never been the experts to write our own motion capture software. I've done it before, but like we vastly prefer to just buy it. So now we do
Yeah.
that. And our kind of expertise is taking that data and actually gleaning insights from it and being able to make the players better than the status quo, like using it as a real actionable source of data rather than just kind of doing nothing with it, which is basically what most of the teams do. They just ingest all this data they spend a lot of money for and then don't look at it, right? Which you can say about, EDR and antivirus and whatever. It's the same as most companies. They're just ingesting all these logs and not reviewing them. So it's no different than that.
Yeah. Okay, so as the CTO, I'm kind of curious, what are some other things that you do differently, or maybe are sort of unorthodox approaches? Because I know you're not somebody who sort of tolerates the status quo if you think it could be done better.
Yeah, I think some of the things, I mean, it's a lot of what we see or what I've seen in technology as well. A lot of the problems that we're dealing with or opportunities are the exact same as most technology companies. Although it strikes me as, it's crazy to me how much, not, I mean, there is some pushback, but like the slow, what I believe to be the slow rate of adoption of large language models in these companies. I don't understand it. I really don't. It's crazy to me that like otherwise very intelligent individuals say that the code that it outputs is poor or whatever. I don't quite understand what type of code they're writing if they think that. But there's so much. We write code so much faster at Driveline as a result of these large language models. We were very early on to purchase licenses for everybody. All the full timers get access to ChatGPT and Claude. We have the APIs running, transcriptions. A big thing that we're doing, which is really no different. Like if you read like Ray Dalio's Principles book or a bunch of other people about meetings, like all the meetings we have, we record and then we transcribe and then we summarize using large language models, OpenAI Whisper. And then those things are appended to we use Notion to like append it. So if you miss the meeting, you don't have to watch a 1 hour video, which no one's going to do. You can just read a 1-page PDF to get caught up. And then we do like pre-training of Whisper to basically say like, hey, these are common phrases that you'll probably get wrong. Here are some ideas. Here's who we are. And then we just front load prompts. And then basically our transcription tool, you upload the video, and then we have all these like options where it's like, is this a company meeting? Is it about player development? Is it about whatever? And then we just swap in prompts based on, the topic of the meeting and who's in it. And it allows us to like semi-customize these meetings. And then we also do train, we do train and fine tune like the Llama 3 variants for some other advanced reports and some other things we do. So large language models are a huge part of our business. They need to become a much larger part of our business. We're not using them as much as I think we should. But then I'll talk to like my friends, whether it's in Silicon Valley or baseball, and I'll just ask them how they're using large language models, and they're like, not that much. It's like, all right, I feel good that we're really, really far ahead, and I can't believe, because I know what it's done for our productivity. I know what it's done for us. It makes our employees so much more productive and capable. It eliminates so much of their boring work that I just don't understand, like, why it's not a big part of everyone's life.
So I'm kind of curious what kinds of projects you use it on. I mean, everything is a reasonable answer, but more like, I mean, what does everything consist of? So we've talked about like motion capture stuff. We've talked about like synchronizing things. Are the people who are using it, are they doing that for that type of stuff? Or it sounds like that's a lot more off the shelf now, or what kind of projects?
A lot of it is summarization and like elimination of repeat work. So for example, like we have these tools that use, just GAMs and basic statistical research to, they're complicated models to basically say like, okay, this pitcher is going to play tomorrow. He's one of our clients, pays us a yearly fee. And here's all the data from all the hitters. Here's all the pitch data. Here's how we train them. It gets synthesized in its model, and then it outputs like a PDF, like a really beautiful PDF of like strike zone plots, like where you should throw the ball against these hitters, how you should attack them. That's awesome. Now we're training a large language model. This is something where we're actually fine tuning a large language model to give us, like, take all that information and give us a script. Because right now, like a hitting coach might have to do like 8 of these, or a pitching coach might have to do like 8 a week. It's a lot. Like they have to prepare scripts, call the athlete, talk to them, be like, hey, here's the things to do. It'd be a lot nicer if that script and the notes were like pre-compiled. So a large language model is like perfect for that. If it could just take all these notes in and then basically say, and then how we fine tune it is like, here's examples of good transcriptions of an athlete and a coach. Like here's this, and then and then we just take that, fine tune the model, and then give them the data, and then hopefully it outputs a script in a similar format. That's like a really good example of fine tuning, probably having a bright future in large language models, which everyone kind of is down on fine tuning, and I understand because prompt, tweaking has become so much more powerful. But like when you need to constrain the format and constrain the output, like fine tuning is really valuable. So that's like one area large language models have been really valuable to us.
Okay, so when you say script, you mean like the actual dialogue between the coach and the player.
Yeah, in this case, yeah, actually,
right, yeah.
Script, yes.
Just to clarify, we talk about a lot of scripts here, but not usually those.
No, good point. Yeah, no, like actually written. So so the person can have all these notes in front of them. It just gives them like bullet points in a script to read off, so they don't have to write it.
Yeah. No, that makes sense. I was going to ask, like, do you ever try to do it in the voice of the coach? If a coach has a particular way of speaking, try to, sneak that in there. But if it's just bullet points, then I guess the coach will.
Yeah, I think in the future we probably will. Their style is captured because we fine tune a model based on what they say. We transcribe those, so it is. But I think in the future, like voice cloning and things like that are probably coming too. Yeah. Also,
coach just calls and leaves a voicemail.
For sure. I mean, also there's concept of like training your interns. Like, for example, if you're an intern at Driveline, you're 20-something, we're not going to trust you to train an MVP. It's just not going to happen. Like, you're not going to be in a room alone and like giving him information. Like, we're going to have our best employee on that. But there has to be a path for this intern to then, work with our most trusted clients. So something we're excited about is like, can they give... here's all this data we have on a player. Based on all this data we have on a player, we know how our best coaches would interpret the data in the reports and how they would communicate it. So we know that thing. Mm-hmm. And we have tons of examples of those recorded meetings of successful athlete meetings. Well, that seems like something that we should be able to train some sort of artificial intelligence and machine learning layer on that, whether it's a large language model or not. We should be able to say, here's a bunch of examples of good speeches, here's a bunch of not good ones. Like, can we have something where the athlete, and then we give like 10 examples out of the training set. So instead of, they're in the test set, and then we give it to a person and be like, hey, based on all this data, this is a picture, like speak into this microphone, like, talk to the person, like, how would you go over these things? And then we transcribe what the intern says over 30 minutes, for example, and then we grade it automatically using, so it's just an eval, where it's like a large language model eval. And then that intern's full-time person that they're paired with gets these reports, like, here's their training. Because right now what they have to do is the intern sits in with a full-time employee. They give their opinion on how to do these things, and you can see how much labor this is using, when in reality, like an intern, and it's also gated, like, what if the intern really wants to learn and work like 10 hours a day and like really focus on this stuff? Well, they can't, because like, the full-time employee's got another job. So it's like, what if the intern could just do this and speak into a microphone in a secluded room with his data and be like, okay, Sam, like, you should do this, these are the exercises you should do. I noticed this. And then we have the answer key somewhere on the back end, and then it automatically just evals, and then the coach gets the evaluation. Like the person scoring 87% based on this, completely automated. But then the coach can, like, importantly, we'll have a reinforcement learning layer where the coach is like, I agree or disagree with this grading by the large language model. And then we can just have this reinforcement layer constantly update itself, which is what we need to do now. We do that currently right now, actually, just not in that context. Like we, based on all this data, do these drills, and our coaches will be able to push like a thumbs up or a thumbs down button, just like the OpenAI thing. And it's reinforcement learning. Like, I agree with this drill, I don't agree. So we have these like experts, human experts, giving reinforcement learning to our algorithm.
Yeah, that makes a lot of sense. I mean, it's basically an onboarding tool. It's like, somebody doesn't, they can get instant feedback rather than being, like you said, gated on how much time is available for the experienced coach. That's really cool. So, I mean, it really sounds like you're leaning into like every single part of the business. Is there some way that we could improve this with this new technology that didn't, exist or wasn't capable enough 2 years ago? You're right there on it.
Yeah, every 2 weeks, actually, we have like a R&D, kind of like an all hands, we call it our technical sync, because basically like, IT is changing these systems, sports science is changing these systems. So we just get all the technical managers together to basically say like, hey, here's technical changes coming. So we make sure that dependencies are set up or pathing or whatever. And in that meeting, I dedicate, it's 30 minutes long only, terminates after 30 minutes, no matter where we're at in the meeting. But in the end, if we have time left over, it's literally the question I ask all managers and full-timers is like, what have you used, what have you used OpenAI for, like GPT, Claude? Yeah, like what have you used it for in this last 2 weeks that we haven't used before? Or it can be boring, I don't care, but like let's just talk about that. So it's a big focus in our company.
Yeah, I mean, something I've noticed is like, I mean, less so today, but I mean, certainly when these things were first coming out, I did a lot of experiments and trying things out, and some things worked, some things didn't work. I'm curious, like, what are the things you found like worked out really well, and what are the things that you tried and you were kind of like hopeful of, but like it's like it just didn't pan out, like it's not there yet, maybe?
I think what most everyone has tried, I think, and have found out that it doesn't work is like anything with like tabular data numbers,
Ah.
like anything involving computation. Obviously, it's not what they're good at. Like it's just not understanding that tokenizers don't lend themselves to like that kind of work, right?
Uh-huh.
So being able to like, oh, here's a bunch of numbers, like based on these numbers, calculate what they should do. It's like literally the worst possible use of a large language model. It's like, it can't tell, like, as the joke is on Twitter, everyone's talking about is like, they can't tell that like 9.11 is less than 9.2, because like just how the tokenizer works, it doesn't work that way, right? So like that was probably the biggest area where we had to be like, okay, like this is no good. An area where I think you can really help in like cloud projects, custom GPTs, and like that approach where you're like front loading prompts, which is all those really are, right? Using a knowledge file or something like that has been really valuable. Is like SQL querying, being able to like dump your schema into a front loaded prompt or a GPT or something like that, and then being able to be like, hey, I want to query this. Like, where should I start? And then using the knowledge embeddings to give you a decent idea of what like the best architecture would be for your SQL query. That's been it's been a really good use of it. And foreign language translation. So we have a custom GPT where we uploaded a ton of pairs. Like we hired a translator, and like we would naively just use GPT-4 and be like, translate this from English to Spanish, like these things, and then give it to him and like be like, all right, what do you think about this? And he's like, no, right? And he'll correct mostly like baseball specific terms is what it's going to get wrong, like slang and things like that. So then in the prompt, we'll just say like, hey, like when you see this, like use this, like these things, these are how you should talk about these things. And the translator gives like full sentences and whatever. So we just kind of like preload the prompt. And now we have a custom GPT that's really good for Japanese and Spanish. And then it passes. Like when we eval it with translators or just like foreign language speakers, they're like, oh, that's like, couldn't tell. So it's a really good example of it. And I recently gave an interview with the Washington Post about how like large language models are like the universal translator machine, right? Like, and that's foreign language, and that's C to Python or Python to C, or that's like an idea to a vision thing, like with image generation, right? Like you're translating your image to a picture or a graph with code interpreter, you can do that too. So that got quoted in the Washington Post, and I think it's a pretty good summary of how I feel about large language models. It's like, it's the universal translator we've always wanted.
Yeah. Wow. Okay. So, follow-up question. One of the things I've noticed about a lot of people I know who have been doing a lot of AI experiments is that there's a common trend of people liking to use LLMs to assist them in writing code faster, but not specifically Copilot autocomplete, like the inline autocomplete thing. I'm curious how you and your team feel about that one.
Yeah, we were first with GitHub Copilot, before all this existed, and it was okay. Like I thought, but we ended up not using it that much, and it ended up becoming. It wasn't until like GPT 3.5 and 4 had been released and using it like that was like, oh, okay, this is like way better. So I would agree, for whatever reason, the Copilot stuff has not been that valuable. Where I find a lot of value in it is being able to like write like detailed comments and like doc blocks, and then having it flesh out like the, basics of the code or code that I've written in the past that I need to like document, just being able to read it and then generate doc blocks for me because I'm too lazy to do that. I think it does a really good job of that type of work, but like live autocomplete, it could be the fact that I'm too old for that, but I haven't found a lot of value in that, to be honest.
Yeah, I'm the same way, and I've talked to a number of other people who are that way, where like for me, I turn off. That's like the first thing I do is like, turn off the autocomplete, because I like to talk to it in sentences. Like I'll say like, I write me a function that does this, or I have a function that does this. Write me a comment that summarizes what it's doing or something like that. But the autocomplete, I think the problem for me is that because it's in real time and it's coming in whether I want it to or not, it feels like I'm constantly context switching. Like it's asking me to do code review all the time. It's like I'm trying to write this thing. It's like, hey, review this code. Hey, stop what you're doing. Review this code. Review this code. And maybe if it were like almost always, I'm like, yes, that's great. I keep it. Then I could feel differently about it. But so often my review is no, throw it away. No, throw it away. No, throw it away. That it just feels like a net distraction that's not really actually helping me. Whereas on an opt-in basis, I've found it's very useful.
Yeah, that's how I feel. I don't like it popping up and giving me the autocomplete, but I was like that too with like IntelliJ when I like had to write Java way back in the day. Like the autocomplete functions those had, I didn't didn't care for it either then. So I don't know. It's actually kind of interesting. I don't know how many people are actually interested in that kind of stuff or like it. I assume a ton of people do. I mean, like Cursor and the others launch it. But for me, it's the closest I'll get is the inline editing, like Control K in the Cursor IDE, which I find is quite good. But generally speaking, I don't like the Copilot stuff.
Yeah, I also am a big fan of the inline thing. I don't know like when this episode is going to air if that'll be in Zed stable yet, but certainly in Zed Nightly, I'm a big fan of it.
Yeah, it's tough. Just the Copilot stuff to me. I gave it like for a long time. There was no OpenAI GPT, right? There was none of that stuff. Just Copilot was the first
Yeah.
thing. So everyone at Driveline, I think, gave it a pretty long leash, and I can't think of a single person that used it like extensively. I think pretty generally people were like, it's fine, I guess. You know, like no one was like pounding the table like I am with like GPT-4. You know.
Do you think that that's like when you talked about like people don't adopt like today's large language models more broadly? Is that maybe because they tried Copilot and didn't like it? Or I guess I'm kind of curious, like in the baseball industry, or maybe I guess there's more to it than what you're doing than just baseball. But I wonder about like, is there a bias towards not adopting new technologies? Or do you think this is just in general, programmers are not trying this? They're not getting as much out of large language models as you think they really should be.
Yeah, I don't know what it is. I think a lot of it is the prompting bothers them. You know, like they expect. I see this complaint a lot, which is people are like, oh, they need to fix like inferring intent or something. Like I shouldn't have to say this or whatever. And my point to them is like they treat it like it's Google. Like you can just like say whatever and then it corrects. And then because we get so used to Google, you can just type whatever and it generally figures it out. And I guess like my point to them, what I've always said to them is like, you can't talk to a human. Like you can't just say a bunch of nonsense to a human. And they're like, oh yeah, I understand what you're saying. You know, like what I've noticed is that the people that complain most about, I shouldn't have to be precise to a large language model. I shouldn't have to trick it. I shouldn't have to have custom instructions or whatever. Like mostly what I've determined from these people is that they're really bad communicators in real life too. Like they don't like documenting things. They don't like whatever. Like when you speak to them, like they're not very good orators or communicators in general. It's like, oh, like you just don't like doing that. Like that's fine, but like you have to treat a large language model. It's very tough to do this. Like it's counterintuitive and like goes against your human will, but you have to treat a large language model like it's a person. Like it's AI. Like it is AGI. Like I don't know what to tell you. Like for like 20 years, we're not going to have AGI because no one's going to be able to define it. In my opinion, we already have it. And so it's like you have to speak to it like a human. Like you speak to it in sentences, like you said. Like you speak to it in sentences. You have to be very clear. You have to be very precise. And so much of my code, when I'm trying to have it debug it, I'm just abusing like fprint and printing and just log dump. I'm just dumping all the variable states, right? Because if you're going to debug someone's code or you're doing pair programming and you want to like look at someone's code and they just send you the code, you're like, well, if you run it, like what are the variables? I don't know what the states are. Like, can you dump the variables or, whatever? That's what you ask typically,
Yeah.
So like, I need to see the logs. Can you ship a log? Like, that's what you expect. And so like so much of my code just says like log dumping. And then I just say like, this code does this. I need it to do this. And here's all the variable states. And then almost all the time it gets it right. So like that's one of those things where it's like, oh, it should be able to infer these things. It's like, how? Like, but if you were a senior software developer and some junior came up to you and like didn't give you logs, you would be mad, wouldn't you? It's like that's the exact same thing. So I guess like I think people are just generally pretty bad at communicating, which is kind of a heuristic that's always true. And then those people tend to be the ones that are really like they get the least out of large language models. I think that's a huge problem with a lot of the developers I've met.
So logging is a really interesting example. I think I might need to change my long-standing philosophy on logging, which is, I mean, you mentioned earlier that there's a lot of data that people collect and then don't do anything with. And in my experience, a lot of times, a lot of logs are like this, where you just generate gigabytes and gigabytes of logs, and then no one ever looks at them. And then eventually you have some problem. You're like, let's go look at the logs. And it's like the one thing you're looking for wasn't actually in there, or like the logs still didn't help you solve the problem a lot of the time. And I'm not saying the logs are useless, but it seems like there's a really big mismatch between how much effort goes into logging things and how much value is gotten on the other side of that. But that might actually change with large language models now. I mean, I actually had my best experience with this was I had a seg fault in some like really low level code I was writing. I ran a backtrace, like I opened up a debugger, backtrace, and I was like, I don't understand what is going on here. I can't figure out what the problem is. I just copy pasted the entire log of like everything that had been going on, the entire backtrace, into, I think it was GPT-4 at the time. And it was just like, here's your problem. I was like, that actually is the problem. Wow. That was amazing. Like, and so given that a lot of the problem with logs is that like you gather all this data and then like going back through it as a human, I think part of the reason that logs don't feel as nice to humans necessarily to look through is like there's this huge volume of it. It's like there's so much, and like filtering it down and trying to figure out the useful part is this huge chore. But what if you could just be like, all right, I have a couple gigabytes. All right, well, we're going to parallelize this across multiple LLM queries and just be like, does this look interesting? Does this look interesting? Et cetera, until you narrow it down to just like, here's the things that seem like they could potentially contribute to the problem. If you could just turn that into like, I pay a few bucks to do that, as opposed to, so many hours that it would just never be a reasonable thing for a human to do. That's really interesting and maybe changes the value of more verbose logging.
Yeah, I generally agree with you though. Like, we don't have a ton of verbose logging in production. Like obviously for any exceptions, we log a ton of information. But just like as a matter of course, if things are running well, no.
Yeah.
But like I think in dev environments and test environments, we're turning on like log.debug for all of our development, because like what's the difference? We're going to delete all these logs anyway. Like the concept of like all it's understood that all the logs are ephemeral, like in these environments, right? Or all the data is ephemeral in test and UAT and dev, right? Like it should be anyway. But I literally had the exact same thing. It's so funny you mentioned it. I was doing for the truly hacker minded out there. Less people think that I just like sit at an LLM prompt all day. When we were loading a force plate DLL, the sports science software is so poorly coded. It's awful. It would crash our software on this one, and it was like not clear why. And of course, there's no error messages or anything. So I load x64 debug, Ollie debug, or I think I was using x64 debug actually in this case, and just loading it, and then doing like setting breakpoints and doing this, like, okay, when it's seg faults, like crash, like capture this, like what is the actual stack trace, like look at the stack trace, look at the actual heap in the stack, take all that, and like I do that. I've do it every couple of years. You had to do it 25 years ago when we were young, like in writing cracking tools, for example, or anything like that. Like you could do all that. I was really familiar with soft ice and all those other tools back in the day. And every so often you break it out. So I was looking and I was like, okay, like generally I have pretty decent familiarity with all these things, but I just like couldn't figure out what was going on. And I was like, you know what, I'm going to turn to a large language model, and then just dumping some of that stuff in there. And it was really, really helpful being able to figure out like, oh, it's like it didn't give me the exact problem, but it gave me way better like memory insight on like where to look for, like do these things. And it eventually helped me solve the problem. So yeah, it's huge. And where like Google doesn't help at all for those things.
Oh yeah, no, absolutely not. Yeah, I think like maybe some of the people I've talked to seem to have this sort of like binary thinking where it's like either it's like this is dumb and useless and I'm not going to use it, and we're all out of a job. And it's like those are the two states, and there's no like intermediate state of like maybe this is useful and I can use it to do my job better. And obviously a lot of people are in that middle state, like somewhere in that spectrum, but like yeah, it's weird that doesn't seem like the norm somehow.
Yeah, it's a country of extremes in many ways, right? We have high variance in our economics, political opinions, attitudes. It's
totally.
It's how we are in America, So I think that's just part of it. But it's also one of those things that's hard to understand. It's funny because it's not like this is the first type of technology that's been transformational. It's it's like, oh, they're all good. Like the bookkeepers versus accounting is like my favorite one. It's like when spreadsheets were invented. Yeah, it's the exact same conversation. It's like we're going to be out of a job. Can you imagine being an accountant without spreadsheets? Like what was that like? It must have been insane.
Oh wow,
and then
yeah.
they exist, and then all these bookkeepers are like, because they're keeping a literal book, right, handwritten or type fonted maybe, and they're doing all the calculations on a 9-function calculator or whatever. And spreadsheets are invented, so it's like, oh, we're all going to be out of a job. And then, like, literally, what happened is like the number of bookkeepers like went down, and the number of accountants went up. Like and it was the exact same. Like bookkeepers plus accountants like equaled the exact same number.
I never knew about that. Wow.
It's a famous quote. What happened is bookkeepers became accountants. Like that's just what happened. Obviously, some bookkeepers got laid off and like didn't reskill, but like generally speaking, those two were completely like collapsed into a single job, and they basically moved, at the same rate. And like that's basically what's going to happen here. It just allows what I have seen happen, and what is happening at Meta and the others that have been reported, so this is not like non-public information, is that you have these senior directors like L6, L8 or whatever, they're being promoted, and then suddenly, like, to justify their salary, they have like 6 direct reports. And, like, they don't want to do that in a lot of cases. Like, they want to be a developer, but the comp is so high that, okay, fine. Then what happens with the layoffs is, like, a lot of their direct reports are laid off, and then they end up with 1 or 2, and they say, like, hey, like, I can do a lot of the junior dev work with these large language models. I don't mind it anymore. All this junior dev work I hated to do, like, is suddenly very easy, and then, if these layoffs mean, like, I can give my junior developers, like, non-trivial tasks rather than these stupid, like, can you change the color of these things, these CSS things, right? Some of the, add doc blocks, all very, like, basic level 0 type stuff, and large language models are really good at maybe automating it someday. I'm very bearish on agents. I just don't fundamentally believe that these things are going to be any good. It's the last mile problem that we always have with these things. But if you can, like, pseudo automate a lot of this stuff, that's what's happening, I think, in a lot of these companies. So, like, a lot of the trivial work is being pseudo automated, which means, reskilling is going to be required. Like, the role of the developer, I think, will be a little bit different.
Yeah, one question I'm kind of curious about is, like, a recurring theme of some of the things you've talked about is, like, you've got a large language model, you can make its output better by having an expert review it. So whether that was like the translation or your coaches or whatever, I imagine the same situation sort of coming up in the context of, like, junior developers who are people who are starting out their career. Like, reviewing becomes such an important skill that if you're starting out in your career, you of course can't have that skill yet. Like, you don't know how to evaluate the quality of the output of a large language model yet. I'm really curious to see how that pathway is going to change, because, like, you're right. I mean, if you're starting out, a lot of stuff that used to be sort of like, oh, this is easy, just go do this thing. It's like, yeah, it's so easy that no human should do this anymore. So, like, nobody needs to do that. So what do you do instead? And what do you do instead that can get you on a path to eventually becoming an expert reviewer, which feels like kind of table stakes for getting the most out of large language models? Yeah. I don't know if you have any ideas on that.
There's a perfect, I have an eval that's perfect for large language models that comes up every time. And every model but one has failed it. I haven't tried Sonnet because it hasn't been relevant in this. But I had to use another model, which was Find. I don't know if you ever heard of it, like phind.com.
I've heard of it, but I haven't tried it.
Like, purport to be a coding specific. It's like a deep seek coder type model. Like, it's a coding specific, and that's the only model that gets this right, which is, like, very surprising. But it's in CV2, so OpenCV, the library, computer vision in Python. I'm sure this bug exists in the other ones. But when you ask it to, like, facial recognition specifically, like import face recognition, like, very popular package. Like, write something that, like, every frame, like, parse the facial recognition. Like, do this, like, get the landmarks and, like, do embeddings. Like, it's simple k-means clustering, like, is what it uses. So it's like, do this and, like, embed this or whatever. Every single model I've used, every large language model, except for Sonnet, since I don't know, gets it wrong. Like, it outputs code and then it crashes immediately. Like Python, it's just incorrect, like, how it does the embeddings. It uses, like, you can tell because it, like, in the code, it'll use, like, x1, x2, y2, y1, like, it uses a tuple for this. And, like, it's definitely the wrong way to go about it, and constantly leads to either seg faults, or it leads to just, like, no data being found on this. It is consistently the wrong embedding method. And my theory is that, like, there's just not a lot of code written on that OpenCV approach, and the code that was written was wrong, or was, like, maybe correct in a previous version. So all of these large language models know it's just this, and because, like, it never came up in the RLHF, like, retraining step, is that no coders did it. Like, in the people that were paying $5 an hour to do the RLHF, like, that never came up. So as a result, it's just in their production models. And again, the only model I've ever seen is Find. That gets it right. So, like, that's a thing that if you just use LLMs, and if you Google for it, it's also true that when you Google for that, you get no good results. Like, you see on Stack Overflow people discussing it, and there's no definitive answer, which is, of course, what you would expect if the model doesn't get it right. So that's, like, a perfect example of you actually need to know CV2 to, like, fix this problem. Otherwise, like, you actually need to know what's going on with the face embeddings, which you would never know unless you understood OpenCV from the beginning. To understand OpenCV, you need to understand k-means clustering. You need to understand all this stuff. So it's not like academia is dead. And even if they fix that one niche, which I'm sure they will, like, that doesn't. There's still tons of other areas where, like, are under-indexed online and under-trained, and they probably are mostly to do with math, like, because, like, who writes, like, really deep mathematics code? It's very few people, so as a result, there's just not going to be a lot of good Not a lot of good feedback on that. So anything like that is going to be safe, I think. Okay, so writing a bootstrap site and getting something up, yeah, that's done. Like, I don't do that. I just have Sonnet be like, generate me a Tailwind, bootstrap, blah, blah, blah. All the internal tools of Driveline are written that way. And it's super simple. But is that something a human should have been doing and making 80 grand a year for anyway? No, probably not. So it's like coders can like actually add a lot more value. There's a specific economic, not fallacy, but like principle where it's like as additional automation is added, right? It's not that. It's like when the quality of an item goes up, or like if productivity goes up, people think like, oh, jobs will go down. And actually what happens as productivity goes up and like the quality of their tools get better, consumers just demand more at the same price point. So it's like, it doesn't solve it. It's like, oh, the productivity has gone up, therefore we can charge more for or we can charge less and whatever. And in reality, what happens is the revealed preference is the consumers see better products and they're just like, oh, this is a better product. It should be 10% better because consumers are never happy. So there's this economic thing that's like, as productivity increases, no jobs are lost as a result because consumers just demand better and better things. It's a really cool economic thing. I can't remember. I studied econ and it was a big thing of it. It's like when the cotton gin and things, it's like, oh, it's going to put all these sewers out of thing. It's like, hey, our clothes don't suck. They should consistently not suck. And they should actually get better. So as a result, like nothing changed. Like, consumers just have higher demands over and over and over again. So
yeah,
that's like,
bookkeepers become accountants. Yeah.
It's one of those things. It's like an economic thing. Like computer scientists who don't study economics and like how these things impact it, like tend to have these really extreme concepts when in reality, a lot of these things have happened in the past. And like, we can learn from it. It doesn't mean that the AI risk and stuff isn't real. I think it is. But it's just way more, it's going to be through a different mechanism than what they think.
Yeah. I that's a whole long rabbit hole there. Yeah. But you mentioned UAT very briefly in passing earlier, and I wouldn't have thought that this would be a controversial concept, but I have definitely talked to, so UAT, I'm assuming stands for user acceptance testing,
yep.
Which means that like you actually, before you deploy to production, you have humans try out the thing. Is that right?
Yeah.
So in this day and age, I mean, that's actually become a controversial thing. I mean, I've talked to multiple companies, the most extreme example of which was basically I was talking about this topic and someone was like, don't suggest QA, don't bring up QA here. That's not going to fly. If the tests pass, we ship to prod, and that's how things are done here. Which I don't agree with. I think you get better quality if humans try it out before it goes out the door. But I'm curious to hear your perspective on it.
Yeah, that's kind of wild. We work with a software shop, so it's like outsourcing kind of, but like they do quite a bit of our SaaS development, so not internal tools, but like one of our products. We've been with them forever. They're awesome, and they're very strict about it. Like they have like QA, UAT, and whatever. That's their philosophy. I tend to agree with it. They ship these things, they deploy to UAT, we test them as our employees test them basically, and they're just like, okay, like do we agree, yes or no? I understand the other side of it, but I don't know. We've caught so many things in UAT, especially when they're not subject matter experts. For example, like software developers that do front end stuff and work on this, like our team on software, they're not baseball experts, for example. They're not. They're great software developers, great front end, back end, great. But so we don't catch bugs in UAT, like otherwise they would, otherwise they'd be bad at their job. So we don't catch bugs in UAT. What we catch are inconsistent things that don't make sense to a baseball coach. Like that's something UAT is good for, because like they're not experts at that. So when we're just like, oh, this layout doesn't make sense, or like when you click this, like this is a weird, or this wording is weird, or whatever, they're like, oh, okay, great. Like for me, UAT has been really good at that. Maybe if the employees and the consumers are the same, that UAT is less relevant. But definitely in our case, we've got a lot of value out of having a separate UAT branch.
Well, and you also mentioned that company does QA before they ship to UAT, which hopefully is like where they're catching bugs. And a weird thing to me is the idea that if you're saying we don't need manual QA, I mean, kind of implicitly what you're saying is like either the incidence of QA catching bugs before they go out to whatever the next stage is so low that it's just not worth paying anyone to do that, or we don't mind if those bugs go to the next stage, possibly because we're like, well, we'll just roll it back, or we'll only ship it to 1% of instances first, of whatever. But I don't know. It really feels like to me, if you care about all your users and you're not, I guess the level of quality that I want out of my software is not such that it's like I'm like, hey, this thing is broken. Oh, I probably just they just shipped something to me. I'm in the 1%. Oh, well, I'll just come back in an hour and they'll have rolled it back and it'll be better. I don't know. I don't love that user experience. I want them to fix the bugs before they shipped them in the first place. And I've never really heard of a shop where they're like, yeah, our QA people review things by hand and they never find anything. It's like we were never about to ship a bug. It just never happens.
Yeah.
So I don't know.
I was using an IDE and I updated, it's like, you want to update it? And I used it, I updated it, and then it just broke remote SSH. Like, just remote SSH just didn't work anymore. And
yeah,
I was like, oh, it must be me, or SSH breaks all the time. It happens all the time for whatever reason, right? So then I restarted my computer, whatever, reloaded it, and remote SSH is broken. So I was just like, I emailed, and they're like, oh yeah, like in the rolling updates, like remote SSH is broken, like download the old version. I was just like, how are you going to, like, it's a pretty core functionality. Like remote SSH is not like an esoteric, thing. I think a lot of people use it, I think it's like the number 3 most downloaded plugin in VS Code, I would guess. It's like, it's top five for sure. Like everyone uses it. So, especially in the age of GPUs, right? When you don't have one, like you're going to use remote SSH, right? So, I was like, well, what? You're just going to ship like a busted SSH pipe? Like, that's wild. That would be like shipping, and then, stuff like CrowdStrike happens, of course. And it's just like, yeah, okay. Like, I don't know. So I just, and no amount of QA fixes all that, obviously. But having some sort of human layer in there it makes sense to me. It doesn't seem like an area that I would want to cut funding for.
Yeah, I mean, I totally agree. And I mean, if you're shipping to paying customers, I mean, it's a different story if it's like this is your hobby project or something like that. Sure. But yeah, I mean, I agree, and I think it's interesting that you, as someone who's like, this whole conversation has been like cutting edge from, like do as much, automate as much as you can, like get the most out of technology that you can. Like you're still like, yeah, no, but like human QA is good. Like it's worth it.
Our director of software architecture, he's very old school. He studied the middle. He's younger. He's in his 30s, but he before he worked at Driveline, his job was writing JCL COBOL for student loans, believe it or not. Yeah. So a lot of his ethos is rooted in a lot of that. So he's very big on documentation. Not so much pair programming, which I don't like. But if he wanted to do it, that'd be fine. I'm just not a fan of it. He doesn't like it either. But code reviews are manual. Like we code reviews, we actually use large language models for code reviews too. Like we have a GitHub action that will like take the split diff and then be like, here's the differences. And then we have prompts to be like, make sure this doesn't break. We have tests, of course, but then it's also just like, here's future areas. And we have a large language model like summarize, then post an inline comment to be like, here's what's changed. Here's here's some performance areas you may want to look into, blah, blah, blah. So there's like an English summary. So for example, like I can review, say, like front-end PHP code that I don't touch much, and if I can just look at it and be like, oh, okay, like I don't want to read a 1,000-line split diff that was, squashed. Like I don't want to read that. So then I could just read an LLM summary. So that's been really nice. But even with that, he'll take those notes, and then, when he goes to deploy, before they deploy, they have a synchronous meeting for like 15 minutes. I'd be like, walk me through the code, blah, 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 this. Like we have manual code review here, which I think is good. People tend to like it as well.
That's another area where, going back to something earlier in the conversation, it seems like there's a pretty big, I don't know, maybe overlooked opportunity for, if I'm going to seek code review from someone else, shouldn't that first person be an LLM? Because maybe they'll tell me incorrectly that everything's great, and maybe I still want to have a human review it afterwards, but it could be like, hey, I'm pretty sure this is going to have a big performance problem, or I looked at your code and I saw this one thing, and it seemed like this is something that if I were a human, I would give you this feedback about. And maybe you can then just be like, oh, I agree. I'm going to go fix that before I, waste one of my coworkers' time looking at it and saying exactly the same thing. And maybe after I do show it to the coworker, they come up with something else. But like, there's no harm in just saving time by just getting some piece of feedback that I can look at and either reject or accept parts of.
Yeah, exactly. Just analyzing split diff is cheap, so we just call Sonnet. And then have it, the GitHub action calls it, gets a response. We front load with a prompt and be like, this project, we'll like read it in also like a part of the readme.md, for example, or like what is this code, some sort of embedding to be like, this code does this, these are the aims of this code. And then it'll just like do whatever. Typically we'll just dump it the requirements.txt file, like if it's a Python project. So it just sees like, oh, these are the types of like calls that you can make. and then it'll like look at that and then summarize it. And those have been awesome. Like just to have those commits in there, even for my own code. Like I push code today, and I'll just analyze it and be like, these are the things that have changed. These are the performance changes. We're chasing down a bug, for example. Like we read when the baseball's thrown, a radar gun reads it over RS-232 serial. We capture that information and like trigger our cameras. It has to happen in like a very small window, so it's very latency sensitive. And in Washington, it's acceptable. In Arizona, it's not. Like we don't know why there's like a 1 second difference, which is a huge amount of time. And we don't know what the difference is. And it's been really hard to figure out why. Like low level log analysis has been like, the equipment's all the exact same, we think. And it's like very difficult to tell. Yeah. So large language models
facilities, right? Because you have a facility in Washington.
Two different facilities, but like what is it? Because it could be like the radar gun transmits over Bluetooth. There could be Bluetooth interference, right? There could be a ton of different stuff that is causing these latency issues, and we've like chipped it down consistently. But we don't know the root cause. And so being able to commit these things with a large language model. Large language models have done a good job of being able to like analyze huge amounts of information. Like basically I'll take like huge captures from Wireshark and just be like, hey, here's all this, or USB PCAP, and just be like, hey, here's all this. And it's like, no, there's no difference in here. And then I've even paid like, pretty expensive contractors to take a look at it and be like, USB PCAP. And they're like, no, there's no latency issues here. So every time we've recruited a human that's smart, like they've agreed every single time with the large language model. So it's not like we're getting no value. We're getting pretty good value out of it. It gives me confidence that we can give it more and more things to analyze. It's almost like a static analysis tool. Obviously, that's not the right word for it, but it's like that. It's basically like a first pass of it before we have humans involved, which makes code reviews a heck of a lot faster. Because instead of like, oh, please submit your code and bullet points and documentation, the coder doesn't even do that anymore. Like they prompt, like every function in our code base for Python has to have doc blocks, like a lot of places. But in this case, they're just auto generated, and then the summary of the code review is auto-generated, so the employee doesn't have to write like a one-page memo on the code review. It's already done, So then the architect can just be like, okay, here's the one-page review, here's this. Okay, I don't agree with this approach. Have you considered this approach? It's more like an esoteric thing, like typically like caching or like cache invalidation or like these things. Have you considered more of like, it's more theoretical than it is coding. And that's where an architect really comes in handy, where a large language model only gives you the answer, you're asking it for. Like, it's not going to necessarily suggest like other approaches, algorithmic approaches. So that's where a human, I think, is really valuable.
Yeah, that makes a lot of sense. I'm naturally curious about, it sounds like you're obviously very happy with large language models overall, including things like documentation and summaries and whatnot. Have you ever had any like really bad false positives or false negatives where it like really got something wrong and you're like, oh, this actually cost us a bunch of time, even though overall it's been worth it?
One area that's been not good in my experience has been file system manipulation. Not that I would ever give a large language model the agency to do that. But like writing PowerShell scripts and Bash scripts to like automate like folder creation and stuff, it's like been weirdly bad at these things. Like if you ran these like scripts, like it would just delete way too many. Like it's just been which of course you never really want to trust a robot to anyway. But yeah, for some strange reason, it's been very, very poor at that. I don't see why. It's kind of a very menial task. But I think it gets, I don't know why, but like we have like the way our folders, it's very nested and there's a lot of files. So I have a feeling it gets confused somehow. Like the tokenizer or something is getting confused on like these very, very long nested directories and files. I have a feeling it gets confused and can't keep the like logic syntax in its brain. I don't know what's going on, but I don't use it a lot for that as a result.
Yeah. I've had a similar experience with, and this might be Rust specific, but in general, the like, hey, here's a bug, here's a compiler error, just fix the compiler error. Like, even though it has all the context of the file and what the error was and all that, it's still like it's like maybe single digit percentage of the time it actually gives me the correct fix. It's like I just totally given up on that. Even with Claude Sonnet. Now maybe the future models will be better at that, or maybe it's just Rust specific, because that since this stuff has come out, that's like been the language I've been using most day to day. But I don't know what your experience has been like, but for me, it's like auto fix errors is just not been successful.
No, it's not been good. Like I would say, like because Python is probably the most code, like it's probably the most common code, I would guess, and it's like we write a lot of stuff in Python, so it's been good for that. But auto fixing errors has been. We've actually tried to do that in like exception handling. We've tried to have like auto healing type ideas. It sucks.
Oh,
yeah, it's been so like that's one of my experiences with agents or like pseudo agents. it's the last mile problem. Everyone who thinks like these agents, I could be wrong, but like I think that these agents like Devin and all these other projects, I just inherently don't believe that they're going to be any good, because it just takes one small syntactical error to make the agent worthless, because it can't be like 95%, like large language models are like 90 to 95% accurate. That's great for like how I use them and how you use them.
Yeah.
Like we use them as a pair programmer, just like your coworker is probably like 80% accurate. So you just deal with that, so it's like, it's your coworker, but like it's not, it doesn't have autonomy. Like that's the difference. So like when it has autonomy, it's an agent, 99% is unacceptable. It's just not, it has to be much, much better than that. And like, that's just why I think agents I don't think they have a chance anytime soon without severe increases in precision.
And the other problem that I've seen with that whole category of things is that I don't know if there's a term for this already and I'm just not aware of it, but what it feels to me like is like there's just this LLM asymptote where it's like there's some problems where it's like I will ask it and it's like, I got you 95% of the way there. I'm like, cool. Now let me just give you a little bit of feedback. And it's like, I got you 97% of the way there. And I'm like, I'm so close now. Let me just give you one more piece of feedback. And then like an hour later, I'm like, this is never happening, is it? But you don't know that until you've put all that time into it. And after having done this a few times, I've gotten a better heuristic for like, after like the second follow-up, I'm like, I see where this is going. I'm going to just do this myself. But again, if with an agent, there is no, I'm going to do this myself. It's just like, it's just going to go and get stuck. I would assume. I haven't tried using agents for anything serious, but I have to imagine they have the same problem because they're all based on the same LLMs. So how could they not?
That's a good point. Yeah. An LLM never taps out, like it just like constantly is like, here's this. Then eventually it probably emits the same code as the beginning. And I think as people now understand, which like Claude now has a disclaimer at the bottom when you have like too much long context, it's like you should start a new chat, there's way too much, because like when the context is way too long, like the large language models get confused, because it has to compress it right to fit it in and then whatever. But that's another reason that people don't understand, like when people chat with Claude or whatever and they're like doing it over and over and over again, and to be fair, it's their problem too, because like they're like, save chats, like open up your save chat. It's like, no, like you can't have a million tokens in the context window like that you've constantly and then think you can remember all those things. They don't do a good job of advertising their limitations. So as a result, people get this really negative experience, which is true. Like they'll say like, I said something, and then it gives me my old code back. It's like, no, it doesn't remember that there was old code. It's not like being lazy. It's just like, that's how it works. Like it can't remember.
Right.
It can't remember 700,000 tokens ago what it said. By definition, it doesn't have that embedding anymore. And like that's a really negative experience. One that I understand if you understand large language models, and you do too. But like even your average good software developer may not understand it because like they may not understand tokens and context windows. So then that's a very bad experience.
Yeah, I can see that. And that also, I mean, now that you say it that way, it kind of brings home for me one of the reasons that people might feel weird about or have problems, successfully using these things is that it's like it is a tool, and like a tool, you have to understand how it works and like what to get the most out of it, and what are the tips and tricks to using it. But you talk to it like a human, and with humans, you're not really supposed to treat humans that way. So it's kind of like, which is it? And it's like, well, it's kind of both, So I don't know what to tell you. That's just and admittedly, that's kind of weird and sort of novel among tools we've used in the past.
Yeah, definitely.
Well, we talked about a lot of different things. Thanks so much. Anything else we should talk about before we wrap up?
I think this was awesome. I think we bored enough people on this stuff, but no, I think it's awesome, and I'm really looking for. I mean, the next year of large language modeling and development, especially vision, to me is the biggest area. It's probably where we spend most of our time. Is like incorporating these VLMs and GPT-4V and things like it. It just feels like that there's a huge to me it's like nuts like that. It's not crazy that computers you understand your computer can see now, right? Like it can see and they describe it. They're like, oh yeah, like what would you use it for? It's like it's not really like, why do I have to give you an example? Isn't it just ridiculous that I can see and hear now? Think about how that would change everything. So we're starting to use it quite a bit more, those vision models internally for quite a bit more things, like how many people are in the gym and heat maps, and like where do they go, and like how should we plan the gym operation better based on these heat maps, are some areas that we're using for, which I think so hopefully the next time we talk I'll have more information on that.
That sounds amazing. Well, I'm looking forward to that, and best of luck with everything, and congrats on all the amazing success we had so far.
Thanks, man. Appreciate it.
That's it for this episode. I hope you liked it. I put some links to Kyle's work and some of the things we talked about in the description. By the way, if you've been enjoying these episodes and you'd like to support the show on Patreon, check out patreon.com/softwareunscripted. Bye for now.